Okay, good afternoon class. So today we're looking at rational numbers. Also at this point you guys have taken down the notes. So that we can just go through it easily. So you guys will just fill in as I fill in as well. Okay. So introduction, integers, which is the Z, can be further extended by adding fractions. So in our last lesson, our last topic we looked at was integers. And integers was positive and negative whole numbers in essence. Okay. So rational numbers now is going to be your integers plus your fractions. Okay. The definition of a rational number is an integer over an integer. Okay, one number that can be written as an integer over an integer. So here we can get examples of rational numbers. So firstly 3 can be written as 3 over 1. Any whole number can be written over 1. Any integer can be written over 1. So 3 is 3 over 1, a half, your fraction. 1 and a half can be written as 3 over 2. Negative 5 can be written as negative 5 over 1. 0 can be written as 0 over 1. 0,25 is also a quarter to us, not so? Negative 22 over 9. Negative 3 over 4. The square root of 9 over 16. The square root of 9 is 3. The square root of 16 is 4. So that constitutes a rational number as well. We're looking at the square root of 2 quarters. Firstly, we're going to change this to improper format, which is 9 over 4. Square root of 9 over 4, of course, is going to be 3 over 2. Square root of 16 is 4, but 4 can be written as 4 over 1. So this is examples of rational numbers. So what's a rational number? It's a number that can be written as an integer over an integer, or a number that can be written as a fraction. So simplification of fractions, we know that 12 over 18, as you can see, can be obtained by dividing the numerator and the denominator by their highest common factor. In this case, it's going to be 6. And 6 goes into 12 twice, 6 goes into 18 thrice. It's like cancelling or simplifying. Okay. And we have done this in the first term as well. Not so. The reason why we spend so much time on fractions is to make the section of work a bit easier. Okay. So simplification, we know that 20 over 24, as we know that 4 goes into 24 times. Sorry, 4 goes into 25 times, and 4 goes into 24 6 times. The answer is 5 over 6. Divide the numerator and the denominator by the highest common factor, namely 4. Okay, the next one. Divide numerator and denominator by the highest common factor, which is 5. So it's going to give you 5. And 5 going to 49, 9 times. It's giving you an answer, 5 over 9. Okay. The next one, 18 over 9 over 18. If you say 3, and you've gone 3 over, and 3 goes to 16, 6 times. Well, you notice 3 can go into it both again. So 3 going to 3 once, 3 going to 6 twice. So that is not in its simplest form. In other words, I didn't take out the highest common factor. But if you had taken out 3, you must just go a step further, if it can. Okay, and simplify as far as possible, which then gives me 1 over 2, which is half. Okay. Determine the value of x. So let's go here. Determine the value of x. So how do I get from x to 6, from 8 to 16? Multiply by 2. Now to remember, in equivalent fractions, what you do to the denominator must do to the numerator. So how do I get from 3 to x? Multiply by 2 again. So therefore x is equal to? Who will agree with that? Look at the next one. How do I get from 3 to 18? Multiplied by 6. So a number multiplied by 6 is 30. So what's the number? 5. Otherwise, you could have gone the other way and said, okay, if you got x over 3 is equal to 30 over 18. How do I get from... Oops. No. Right. How do you get from 18 to 3? You divide it by 6. So I divide that also by 6. 30 divided by 6, of course, is So either or, you should get the right answer. Okay, it depends how you see it. Okay. Let's look at 2.3. Here we are told that you got negative half is equal to 2 over x. So how do I move from negative 1 to 2? Multiplied by negative 2. You all agree with that? So negative times a negative is a positive. So I multiply that also by negative 2. So therefore x is equal to negative. You all agree with that? Okay, so for those of you looking a bit confused, I got 2 over x, which is negative 4. 2 goes into 2 once, 2 goes into 4 twice. So it's negative half. Did you see that, people? You guys understand? Right, let's look at the next question. So you got negative 8 over 12 is equal to negative 20 over x. Can I move straight from the negative 20 to the, sorry, from the negative 8 to the negative 20? No. So what I do first is I say, okay, negative 8 over 12 can be written as. Now what number goes into 8 and into 12 without remainder? 4. 4 goes into 12. Twice. 4 goes into 4 goes into 8 twice. 4 goes into 12. Thrice. So in other words, that's negative 2 over 3. So negative 2 over 3 is equal to or equivalent to negative 8 over 12. Can you see that, people? So in other words, this must be equal to negative 20 over x. So now we ask ourselves, okay, how do you get from negative 2 to negative 20? Times by 10. So you times that also by 10. Okay? So therefore, x works out to be 3 times 10 is 30. And negative 20 over 30 is of course negative 2 over 3. Which is the same as negative 8 over 2. Yes, Michael?
So for like the first 2.3, so
Sorry?
for the first 2.3.
So yeah, this one, yeah.
Yes. So could you please explain how negative 2 times negative 2 is equal to negative 4?
Okay. This is taking us back to 2.3. The first one, I see they named it two sums at the same numbering. So if I put that negative 1, remember if you got negative a half like that, that's the same as negative 1 over 2, which is the same as 1 over negative 2. It's all the same. You agree with that?
Yes, sir.
Okay. So now if I put it to the 1, you ask ourselves, okay, how do I get from negative 1 to 2? Times by? Negative 2. So if I multiply the numerator by negative 2, I must multiply the denominator also by negative 2. You understand? So what's 2 times negative 2? 2 times negative 2? Negative 4.
So does that mean only the numerator or the denominator can have a negative sign?
Yeah, the negative sign can be anywhere. I just showed you here. It can be next to the fraction, can be in the numerator or it can be in the denominator. But if the negative is here, it doesn't go to the top and bottom. It's either top or bottom. Okay. Does that answer your question? No.
So how do you choose, like, how do you know whether the negative sign goes to the numerator?
I just said it doesn't matter where you put it. Let's put it at the bottom. Remember the answer was negative 4, no? Right. Let's put it at the bottom. So how do I get from 1 to 2? Times by 2. So you multiply that also by 2. So what is 2 times negative 2? Still negative 4. Right. There was a question at the back. Somebody's hand was up at the back. Sorry?
I thought that the negative in the middle was for the entire.
No, the negative in the middle is for the entire sum. What I'm saying is that could be written like that, or it could be written like that. It doesn't matter. So if it's for the middle, it's for the whole fraction. Okay. Anything else? Right, let's go to the next question. 2.4. Look at 2.4. Now remember, 15 is naturally over 1. So how do I move from 1 to negative 2? Multiplied by negative 2. So you multiply that also by negative 2. So therefore x is equal to negative 30. Okay, let's go to the next one. Remember the x is in this denominator here. So how do I go from 8 to 5a? Multiply by 5. So you multiply that also by 5. Not so. Therefore x is equal to 15. Mizan, you're right? Alright. Go to the next one. You all okay with that? Again, the x is in the denominator. How do I move from b to 2b squared? Multiplied by 2b. So multiply 4 also by 2b. So therefore x is equal to 4 times 2b, 8b. Okay. Do you guys understand? See any confusion there? Yes.
Sir, 14.5.
Sorry?
14.5.
2.5, yes?
Sir, isn't 5 times 8, wouldn't it be 8,
5 times 8. Where were you in the first term, Michael? When we told you 4 times C. What's 4 times C? What's 4 times C? 4C, yes. Remember that sum? One of the first sums you gave in algebra. So what did we say? We always write the coefficient in front. Okay, you see the holiday wasn't good for you. Very important. So 5 times B is 5B, and 8 times 5 is 5A, and not A5. Okay? Any other confusion there? No? So comparing fractions. Comparing fractions. In order to compare fractions, they have to be expressed with the same denominator. Then we compare the numerators. Okay? So the denominators has to be the same. Example 1, which is the larger fraction. So you see the denominators are the same here. So 15 parts of 19, is that larger than 8, or is 18 parts of 19 larger? So if you got a pie and you divide it into 19 slices, which is more? A pie that has 15 over 19 slices left, or a pie that has 18 over 19 slices left? 18 over. You see, when I talk about food, then you guys know what I'm talking about. No? So of course 18 19ths is larger than 15 19ths. Not so? Okay, not practical to cut the pie in so many pieces, no? Alright. People, which fraction is the larger fraction? So what do we need to do first here? We need to express the fractions with the same denominators by finding the lowest common multiple of the denominators. So if you look at the numbers here, we got 8 and 10. So what's the LCM here? 40. Not so? So it's going to be 40 here. So it's going to be 40 as well. So 8 times 5 is 40. So 5 times what is? So 5 must be multiplied by 5 as well, which gives you 25. How do I get from 10 to 40? Times by 4. So multiply 7 by 4, which gives me 28. So which one is larger?
Apologies for the interruption. Convalate Quella, can you please report?
So therefore,
Convalate Quella to report it on.
7 over 10 is larger. Do you guys understand? And when we answer the question, we write it in standard in the fraction format that it was given. Yes, Michael.
Sir,
Yes.
so I did it in my head and then
Your head, okay? My head is not so big like yours. So, but I know some of you can see it from the offset from the beginning.
yeah,
If you answer it so, you get your full marks, provided you say. Okay, yes.
But then I made my denominator 80 and then I just simplified it.
So you didn't go with the LCM. You did some. You got the denominators to be the same because you went 80 anyway. If I had gone and said 800, it would also be the right. Because that would have been 800. That would have been times by 100, so it's 500. If you go there 800, so you multiply that by 80. 7 times 8 is 56, so it's 560 over 800. Which one is bigger? That is still given. We had gone 8,000, 8 million, 8 trillion. We all get the same answer. But the reason why we go with the lowest common multiple is because I will try and keep things simple. Not so. But now you, that kind of girl that want to complicate life. But you're going to get it right. Okay. You won't be penalized if you go with 18 already. No? But when you answer the question, you're not going to answer it in terms of the denominator, you answer it in terms of the given number. People, number 3, it says arrange in ascending. People, what's ascending order? What's the biggest solution? The LCM of the denominator. We're going to first get the denominator to be the same. So if you're looking at 5 over 12, well, what is your LCM here? Sorry? 24. You all agree that all these denominators can go into 24 without the remainder? Right, so 12 times what is 24? Times 2, so it's 10 over 24. So 24 times what is 24? 1. So it's going to be 24 times by 1 gives you 11. How do I get from 8 to 24? 3. Multiplied by 3, so it gives me 9. 2 times what is 24? 12. Gives you 12. So we ask ourselves, okay, I ask you to write it in ascending. People, what does ascending mean? Smallest to biggest. So what's the smallest number here? 9 over 24, not so. Which corresponds with 3 over 8. And then 10 over 24, which is 5 over 12. Finish it. Then it's 11 over 24, which is original format there, and a half. That's the answer they're looking for. Could you have done that also in your head, Jan? Sorry? Oh, you wrote it nice. People, number 4, it says arrange in descending. People, what does descending mean? Biggest to small. So what do we do first? We write it in. Find the LCM there. Not so. What's the LCM between 6, 2, 15, 12, 5, and 3? I go going to be counting the biggest denominator here. Okay, which is multiples of 15. So 12 can't go into 15. The next multiple of 15, 30. Can 12 go into 30? No. Next multiple of 15, 45. Can 12 go into 45? No. Next multiple is 60. Can 12 go into 60? Yes. And you also told us what the denominator is. Okay. So
Your
60.
attention please, the following
60.
learners, if they can please
60.
report to
60.
the music department. Zandile Mashlangu, Georgia Peterson and Batia. Zandile Mashlangu, Georgia Peterson and Batia. Then also Mishka Red
Okay,
Nine,
so-
can you please report to the office? Thank you.
So 6 multiplied what is 60? 10. So I multiply negative 1 by 10, I get negative 10. Then 2 times what is 60? 30. 1 times 30 is 30. 15 times what is 60? 4. So negative 8 times 4 is negative 32. Is that correct? 12 times what is 60? 5. So it's negative 35. 5 times what is 60? 12. 36. 5 times what is 60? I just did that one. Yeah. 3 times what is 60? 20. It's negative 4. The question says from smallest, from largest to smallest with descending order. What's your largest number here? It has to be positive, so it's 36, not so. So it's 3 over 5. Followed by 30 over 60, which is half. Now we got 4 negative numbers. Okay. So the smallest negative number is the largest number, coming from the number line. So what is the smallest? Oh, sorry, the largest? Negative 10, which is negative 1 over 6. And then negative 32, which is negative 7 over 12. And then negative, I mixed it up here. Actually, the third one I will cancel out, which is negative 8 over 15. And then negative 7 over 12. And then negative 2 over 3. Do you guys understand? See any confusion there?
Yes, sir.
For homework, from that booklet, where's the booklet? You give me exercise 1. Number 1. Number 2. Do number 1 and number 2. Okay. So will you enjoy this every day? Yes? It's on page 8. Okay, she's now the new girl that's doing that class. You're doing page 8, number 1. Enjoy this every day, people. Okay, good morning class. So today we're still looking at examples for exercise 1. And exercise 1 is on page 62. Okay. So today we're looking at insert a rational, the question says insert a rational number between 3 over 8 and 5 over 7. So what are rational numbers again? The rational numbers are numbers that can be written as fractions. Or it's an integer over an integer. Okay. So we are told you may use any common multiple in this case, not necessarily the lowest common multiple. But we start off by the lowest common multiple. Okay, and if we need more, we then multiply everything by 2 or 3, how much fractions we need between, we multiply it by 1 or 2. Okay. So what's your LCM here? Sorry? 24. Okay, so 8 times 1 is 24. 3. So that's going to give you 9. And then we start by 2 is going to give you
10.
So do you have a number, a fraction that can lie between this with the denominator of 24? No. So what we do is we multiply everything by 2. If they wanted 2 fractions or 2 rational numbers between it, then I would have multiplied everything by 3. You understand? If they wanted 3 rational numbers between these 2 fractions, I multiply everything by 4. This is one more. Okay? You guys understand? So what happens is, if I multiply everything by 2, then I'm going to get 18 over 48 and then 20 out of 48. So what rational number lies between this? Therefore, 19 over. You understand? So say for argument's sake, the question I read, insert 2 rational numbers between 3 over 8 and 5 over 12. So what I would have done was I would have done the initial step as well. And as you see, you can't insert 2 here. So what do? I multiply everything by 3. Just one more. So what do I have now? Would have been 27 over is 12, 72. And that's going to give you 30 out of 72. So if I must insert two rational numbers, what would it be? 28 over 72 and 29 over 72. You see that? Then what do? I can simplify this one here, which will give me 19 over 48. Again. You understand? Or whatever it gives you. If it had said insert three rational numbers between it, then I would have multiplied everything by 4. 5 rational numbers. You multiply everything by just 1. You guys understand? You're checking what 27 over 28 over 72 is?
Yes, sir.
No, what is it?
I don't know, sir.
You didn't check? Oh, you're not checking anymore?
Yes, sir.
Let's check. 28. 2 goes into here, 4 goes into both actually. So it's going to be 7 over 36, 18. 7 over 18. What could be wrong? Yeah, 7 over 18. Okay. Sorry?
I'm asking if she got the answer.
What did you get?
I don't know. I didn't finish checking it, sir.
Oh, I did. And normally we would simplify it in the exam as well. Okay. Always simplify your fractions. We will find two rational. Okay, here's one. Find two rational numbers between negative 2 over 5 and negative 2 over 7. So what we do, we find an LCM first. Not so. So what's my LCM here? 35. So 5 times what is 35? 7. So it's negative 40 times that by 5 is negative 10. So can I list two numbers between this? Yes. Which is? Negative 13 over 35 as well as negative 12 over 35. Or I could have said negative 11 over 35. Not so?
Yes, sir.
Or I could have, I could have listed negative 13 and negative 11 or negative 12 and negative 11 as well. Any one of the two. Did I need to multiply everything by 3 here? No. When do we multiply? If we can't extract values between them. Okay, you guys understand?
Yes, sir.
Is there any confusion?
Yes, sir.
Okay. Common fractions to decimal. We will be done a lot of this already, so I'm just going to go through it quickly. Express with denominators of 10, etc. So if you're going to change it from fractions to decimal, it's going to be easier for us to write it in denominators of powers of 10. The denominators as powers of 10, which is 10, 100, 1,000, 10,000, 100,000, million, and so on. Okay, so it's 10 to the 1, 2, 10 to the 2, and so on. So in other words, this here we will multiply by 2 to get 10 in the denominator, so I multiply it by 2, which gives me 6. And 6 over 10 can be written as 0, 6. How do we get for 25? Times by 4. Times by 4, so it's 32 over 100, which is 0, Can you see that? How do I get from 20 to 100? Times by 5. Which is negative 5. Which is negative 0, 0. Remember there's 2 zeros, so 2 decimals. You see 2 zeros, 2 decimals. Okay, is there any confusion? Right. Next one, we need to change that to improper fraction first. It's going to be 8 to 9, so it's negative 9 over 4. So how do I get the denominator as a power of 10 there? Times by 25. Why? So they can get 100 in the denominator. So 25 times 9 is 45. 18, 22. That's right? 225. There's going to be negative 2, 25. As you can see, it's 2 decimals after the comma, as there are 2 zeros in the denominator. Okay. Again, we have done many of this. Okay. Simply, simply divide the denominator into the numerators here. So we got 19. So we say 19, 000, which is add a couple of zeros here. So this, we can't write this base as a power of 10. Or in terms of 10, 100, 1,000, 10,000 and so on. Why? Because 8 is not divisible by those numbers. You guys understand?
Yes, sir.
Okay. So what we do is we say, okay, it's 19, 000. As we divide by 8. 8 goes into 19 twice. 2 times 19 is, 2 times 8 is 16 minus, it's going to give you 3. Bring down 0. So it's comma, you have it in line. 3 goes into 30. 3 times. This is going to give you 20. 26. 24. So 6. Bring down the 0. 8 goes into 60 how many times? 8 is going to give you 56. 7 times. No? 7 times 8 is 56. You minus, you get you 4. Bring down the 0. 8, right? 5. And of course it carries on. So that's equivalent to 2,375, and the number of course carries on. Okay, the dots indicate that the number does not stop there, it carries. Alright, any confusion there? Yes? The denominator can't be written like it. You understand?
Sir,
Yes?
when you're writing it into it, when we're doing this, do we have to write the 3 dots?
It will be better for you to write the 3 dots. Okay, because if I say that's 2,375, then it looks like it can actually be written as a fraction. So in this case it will be 375 over 1,000. Not so. So if I put the 3 dots there, it's to indicate that it's carrying on. Okay, but we won't penalize you if you leave it out. Okay. People, the next one, 4 over 11. Same story. I just add a couple of zeros there, so it's 4,000 over 11. So I now say 4, divided by 11. 4 can't go into 11, not so. Or 11 can't go into 4, so it's 0, comma. This number is now 40. 4 goes into 40, 11 goes into 40 how many times? 3 times. 3 times 11 is 33. 40 minus 33 is 7. Carry down there, 0. 11 goes into 70. 6. 6 times 11 is 66. Subtract, you get 4. Bring down there, 0. 11 goes into 60 how many times? 3. 3 times 11, 33. Minus, gives you 7. Bring down there, 0. 11 going to 70 how many times? 6. 6 times 11, 66. Subtract is you? 4. Bring down the 0. So what do you notice? What's the next number going to be here? 3. Then, and so on and so on. So this is what we call a recurring number. The number is coming back all the time. It's repeating itself all the time. You guys understand?
Yes.
What do we call it? A recurring number. Okay, so that can be written as 0,3636, and it carries on, which now can be written as 0,3 is recurring as well as the 6 is recurring. Okay, so if I write 0,1 recurring, what does that mean? So if I write it out, what would it be? Can you see? If I say 0,698, all these numbers are recurring. 0,698, 698, 698, and so on. Can you see that, people? Another way I could have written the same thing was 0,698 with a bar on top. Or it can be written as 0,698, 6 7. This all means the same thing. Okay. Okay. Get on with our lives. Decimals to fractions. The common fraction. So firstly this can be written as 2 and 13 over 100. Not so. What will this be? 3 and 45 over 100. So of course 5 goes into here 9 times, 5 goes into here 20. So it's 3 and 9 over 20. Next one is negative 1 and 4 over 10. 2 goes into here twice, 2 goes into here 5 times. So it's negative 1 and 2 over. Okay. So with that you should be able to now conclude of exercise 1 on page 63. You should be able to do number 3, 4, 5, 6, 7 and 8. Okay.